Good morning again, everybody, and thank you for joining our launch webinar on SmartHaul Wireless Network Design Engine. My name is Shimon Hochbaum. I'm Director of Product Management at Siklu, and I will be presenting this webinar today. So here is the agenda for our webinar, a little bit of housekeeping, then we'll start with an introduction. We will proceed with a live demonstration. We will then review what we have seen during this webinar, and we'll open for a Q&A session. If you have questions at any point in time, you can use the window on the GoToWebinar console to send us questions. We will be monitoring the questions, and if I can answer as I go along, I will do so, and if not, I will answer during the Q&A session. And if we run out of time, then we will compile all of the questions and answers in a document which we will make available to all the attendees in a few days. So why are we here and why are we talking about a wireless network design engine? The platform that we have here is something which has been developed internally at Siklu over the last 10 years of the company experience. It's been trialed on medium and very large projects, some of them up to several thousands of links, and we've decided that after we have accumulated all this expertise internally, it's probably a good time to make this available outside of the Siklu to all our partners in a user-friendly way, to enable all of our partners to trial and evaluate designs to see how they can improve or extend their own networks, leveraging all of the experience that we have at Siklu in designs, so that you would be able to decide very easily where millimeter wave links are going to work well, how they can accelerate your rollouts, and do that with really a platform which is dedicated to millimeter wave, so that it will be a lot more easier and faster to do than to try to do the same with some generic tools, which are generally a little bit expensive and very complex to learn and take a little bit of time. So I already told you we've basically taken a lot of tools that we have inside Siklu and we have ported them into a software as a service platform, which means that there is nothing to install for you. It's always it's all accessible over the internet. You point your browser to planner.siklu.com and you will see the login screen right away. The software and all the features that we add are always available. The bugs are always fixed as we progress, and it means basically no maintenance for all of the users. The data that you would put into your project is always backed up and available, so that if somebody would, for example, sorry, technical issue here. I hope everybody can hear well. Um, Good morning, everybody, and welcome to our launch webinar for the SmartHaul Wireless Network Design Engine, or WiNDE as we like to call it. I apologize for the few glitches which we had to start. It seems that some people were not able to listen, so we have restarted the webinar and you have not lost anything. And apologies again for the issues we had with the start. My name is Shimon Hochbaum. I'm Director of Product Management at Ciclo, and I will present the webinar today. The agenda for the webinar is here on the screen. Very simple. We'll start with a few words of housekeeping, then an introduction to WiNDE, a live demonstration, and a summary of all what we have seen so far. And then we'll open for a Q&A session. If you have some questions along the presentation, please feel free to send them along in the question tool in the GoToWebinar. If I can answer as we go along, I will do so. If not, I will do it during the Q&A webinar session. And if we run out of time, I will also prepare a written list of the questions and answers which we will distribute in a few days together with a recording of this webinar. 1 second, please. So what are we doing here? WiNDE is a wireless network design engine which is targeted at designing mmWave based networks. It is the result of a tool chain that we have developed internally over the last 10 years in Ciclo, and which we trialed on the medium and very large projects. Some of them included several thousand of links. And we have realized that now is the time to make this expertise available outside of Ciclo in a user-friendly way to enable our partners to trial and evaluate designs on your own, to check on the options for improvements or extensions of your networks, leveraging all of the experience that we have accumulated at Ciclo, and decide very easily where mmWave links are going to work for you, how they can accelerate your rollouts, and to do so a lot easier and faster than you could with generic tools which are available on the market. These tools are generally a little bit expensive, very complex to learn, and because their nature is to be open-ended to a lot of use cases. Whereas WiNDE, as you will see soon, is very much tuned to the mmWave solutions that we have developed at Ciclo. So WiNDE runs in a SaaS environment, a software as a service. It means that it is available over the internet, just pointing your browser to planner.ciclo.com. There is nothing to install. The software is always up to date. We take care of that, and we'll show you how you can verify what is the status of the current release in use, the features which are supported, and maybe the limitation and open issues or workarounds. Because it is all backed up on the cloud, your information is always available. If somebody goes out on a vacation or on some other out of the office absence, somebody else can easily get into the cloud. All the users of the company have access to all of the projects designed in the company. However, even though we store all the information in the cloud, the data is always your data. You will see that there are means to export the information in Excel files, in KML files, so that you can always look at the information out of the tool, process it in ways which are not yet supported to make your own reports, for example, and things of that nature. You will see that there is a great deal of integration with Google Maps or Google Earth, which are tools that you may be familiar with already, and all this to be easy for you. So let me start now with the live demo. As I told you, you would simply point your screen to planner.cyclo.com, and you have here the login screen. You put your username, your password, which has been provided initially by Cyclo, sign in, and you get in at any point, and that is basically the result. Sorry. And I'm now logged in. A few words about what we see here. First of all, we see some cards. Basically, each card represents a project which can be in any state of design, and you can see a little bit of orientation of where this project is being designed on the card here, as well as some information about how many nodes, the name, etc. What we have here on the top bar is your options to change your name if you want to. An option to change your password anytime you feel like. Here in the help menu, you have about WiNDE, which tells you which version of the tool is currently running, so that you can maybe understand why a design that you might have done 2 months ago is now looking a little bit different because the software would have been updated. You have the release notes with the date when this software was released, the features which are supported, and the limitations or known issues and workarounds are all available here. And last but not least, a complete user manual is available again under this help menu, where you have basically a very great detailed explanations about how to design, how to administer. Every screen is explained with basically all of the information, how to proceed, much more than what we can review here in this first hour of the webinar. And what I'm going to show you in terms of designing a network is one of the ways where to use the platform here. You will see that as you get familiar with the platform yourself, you might develop some other ways or other workflows on how to utilize the platform. I just encourage you to try for yourself and decide which ways work best for you in different scenarios or different use cases. So in order to start with a design, we start here on the plus. We basically create a project, and I say demo during webinar, demo, just some text, which is an additional explanation basically for the name. You can see some of the basic settings for to start the project. Here you have the maximum devices per node, which is going to tell WiNDE how many radios, point-to-point or point-to-multipoint, it doesn't matter, are allowed on a single roof or on a single pole. That can reflect roof heights that you may have, or the maximum number of antennas that you want to see on a pole for aesthetic reasons. It does not really matter. You have a price discount. You will see later that we are going to price the bill of material automatically. And if you know what is your typical discount level, you can put it here. It will be reflected later in the calculation of the bill of material. What you have here is a product selection, which basically tells WiNDE which are the radios that you want to use in this project. And this can be decided based on capacity, on distances, on uniformity, any number of reasons why one would prefer to utilize one or two or just a single or more than 3 models of radios, up to 5. For each radio, you have the radio, it's the distance that is the maximum preferred in that case, the radio, and then the antenna. I'm going to leave the defaults, but I encourage you, if you're not familiar with the radios and their performance, you just go to our link budget calculator that many of you already know, select the radio, the region where the project will be deployed, and then you can verify, for example, that if you like to utilize multi-haul and you want full capacity, or at least a gig, then you should not go beyond 300 meters, for example. So that is what we have here, and you would do the same for the other radios that you might want to use in this project. And I'm going to click Save. The project is now created. I can open it, just double click on it. And from there, basically, I have again the similar screen that we've seen before with the top bar. And what is important, I can, if I want to update the project settings, I can find them again here. What is more important is the 5 buttons that we have here at the bottom of the screen, which is really the typical workflow in order to create a design start to finish. So the first thing to do is to basically enter the nodes which are going to be part of this network. We have 2 ways to do it. We can import nodes via an Excel file, and the template for the Excel file is here. I'm going to show you, sorry, maybe later, a file which is already with the information entered for the nodes. I have another way to do some imports is utilizing a KML file in Google Earth, where you would have placed all your sites with the altitude on the roof or at the street level, and then you just click open and upload, and now all the sites are basically placed on the map properly. And you can also start clicking additional nodes on the map if you want to. That is another way to do this. So you have a lot of flexibility in the way you enter the information into WiNDE. Now we have all the nodes which should be connected into a wireless network. However, we assume that this wireless network is also going to be connected to wired network. It can be with a fiber termination or another mean. Importance is that we should tell WiNDE where these fiber terminations or interfaces between wireless and wired network are located at which node, and we call these nodes the point of presence. We need at least one of those in a design. We can have more than one if that would be the case. and I've just basically right-clicked on this node here, which I know to be the point of presence, and selected point of presence as one of its properties. The next step in the design is to create a line of sights, because as you may know, mmWave links can only operate along a line of sights. So we have two ways to do this. We can, if we know where the line of sight between the nodes are located, we can basically click on this dotted line here, the unconfirmed line of sight, until we have validated, and we can basically start to click between any two nodes where the line of sight exists and add this information to WiNDE, link by link. Or if we have no idea where the line of sights are located, we can just ask WiNDE to create a potential line of sights for us, which is what I'm doing now. Again, different ways to proceed along the designs. What has happened now is WiNDE has looked at basically the maximum link distances according to the radio selections that we have put in the project settings, and then it has assumed the maximum number of neighbors for each and every node on the network. The number here is derived as a minimum of 5, a maximum of 15, but also half of the nodes in the design. We have 14 nodes here, 14 divided by 2 and 7. 7 is more than 5, less than 15, so that is the number that would be used. If I would have, for example, 100 nodes in this network, 100 divided by 2 is 50. In that case, WiNDE would have used a maximum of 15 to create these potential line of sights. And now I can simply ask WiNDE to create a design. And what happens now, the tool is basically going to basically create a maximum of 20 options to realize the design, meaning to connect all the nodes back to the point of presence. And in doing so, WiNDE is going to first of all identify where point-to-multipoint radios can be located and connected, then trying to do an optimization so that we would have a minimum amount of base units in this design. So basically collocate as many links as possible. If links cannot be connected with point-to-multipoint links, then it's going to move over to a point-to-point topology design, and it will combine the two point-to-multipoint and point-to-point at the same time. It will move further and verify that all the constraints of the topology in terms of maximum amount of radios on a pole, distances are observed. It will allocate RF channels to all of the radios and calculate interference if necessary. And all this basically results in what we see here, where for the 20 designs which were calculated, we have for each of them a cost calculation, which is shown here on the green line, utilizing the right scale for the price, so we can see which of the options cost more and which more and which costs less. The tool has also calculated what we call the limitations, and the limitations is basically a reflection of two parameters. One, are there interferences on some link ends, and if so, the limitations is going to go up. Or that's one aspect of the limitation. The other limitation is what is the average distance between all of the nodes and the point of presence, and if the average is higher, then again the blue line will go higher. So we see here that for many of the designs, the limitations and the cost are the same. We see here that for some designs, the both the cost and the limitation is actually not as good as the other ones. So we are not even going to consider those. And basically what I would normally do now is I would select the design with the lowest cost and the lowest limitation if I can find it. And I would start to evaluate these designs by just clicking on them, and that is what I have done here. So I have one option, and I can go back here and check if other options would be more interesting. I can see here on the left the metrics for the option which is currently displayed here under the window, and I can compare with other ones. I can see here that by just moving my mouse to other data points, I can see that the cost and the limitations are the same. And just for the illustration, if I can move here, I can see that the cost is definitely more and the limitations are also higher. Again, it's a very simple design, so there is not a lot of room for changes. You can imagine that if the network would be more complex, there would be more variety in the results, and maybe this kind of window will make it a lot simpler to understand where are the more performant or the lower cost designs. So I'm going to proceed now with this design which I've selected here, and you can see that the design is very simple. The first BU is serving a number of nodes here, and one of the nodes has been selected to locate an additional BU with another sector pointing into a different direction to serve the additional nodes. Very simple. So now I have a topology. I can look at the constraint compliance. Nothing here is out of the ordinary. The average number of hops is 1.5, easy to understand. All these are one hop away. All these are 2 hops away from the point of presence, to clarify what this hop count means. And the average comes out to be 1.5. That's how it is calculated and was reflected earlier in the limitation. We see that there is no issues with the other parameters, such as maximum links per node or interference. All is okay. If there would be an issue, all would be available here under the different categories, the list of the nodes where the issues are showing up, which are hyperlinked, would allow us to very easily jump into the design. We could also export all this information into an Excel file if you want to show some nice graphs, for example. But so at face value, this all looks okay. Now we still have the issue of line of sight. Remember, we just asked WiNDE to create some potential lines. Before we go forward, we would have to validate the 13 links here, whether they have or not a real line of sight. So I can do that very easily. I can go into the line of sight button here and ask WiNDE to create a KML file. And for example, I'm going to check the link from here, the pop, to node number 1 and see if all is okay. So I'm going to export the KML file, and then I'm going to open it in Google Earth. Sorry, it is on my other screen, so I'm moving all this here now, and I have the design here. In the KML file, I have a number of folders which were created by WiNDE. I'm going to explain all this. We have the site data, which is basically all the different nodes which are in the design with their, the name as it was created in the original KML file, and then obviously the latitude, longitude coordinates, and the altitude, which was also created in the original KML file. So all of the information which we had originally is present in this folder. Then we have a line of sight, data, and then we have network design folders, which we are going to look at in a moment. The line of sight is what we want to do now, and I'm looking for this link here, which is between the POP and node number 1, and it is now showing up on the screen. I hope that you can all see it. In order to confirm the line of sight, it's very simple. I select the link that I want to see, and I ask for Google Earth to do a run across the link. It will be very easy in this way to see if there is visibility. And we can see that the link has gone through a number of trees in this area. So obviously this is a no line of sight. I can go back to WiNDE again in this line of sight stage, and I can now go here, right click on the link and mark a no line of sight on this link. I should do this for all of the links which were selected for the design. For the sake of the amount of time that we have during this webinar, I'm going to skip this, but I'm going to now basically run again the design, and you will see that because the link here was not available anymore for the tool, the design has changed somewhat. We have now actually utilizing the same parameters. This sector has not changed. This sector is new, and this sector is also new, so that now we can reach the node which is here in a different way, but with hopefully line of sight. And I can check again my constraint compliance. I can see now that the hop count has gone higher because a number of nodes are going to be served by 2 hops rather than 1. All the other metrics look okay. So I can now proceed to the next stage, which is basically looking at the bill of material. So it is all in this 5th stage. I can basically, the tool has created for me already a bill of material, meaning for each and every node in the project, all of the radios which should be located at this node have been assigned the proper part number with all the right metrics. The tool knows all the details about what comes in the box, what is not included in the box, and what are the options to be added. So in case of a base unit, the antenna is integrated, the mounting kit is included in the box, the PoE supply is included in the box. We just have an option to decide whether we are going to ultimately connect to this base unit with Cat5 or with an SFP, multi-mode or single mode. I can just select it here. Do I have enough capacity with the basic 500 meg, or do I need to upgrade to the full? Sorry. And that is what I've done here. And I can also say, well, in order for this network to actually work, I need a non-penetrating 2-meter mast, and I also need 100 meter of multi-mode fiber to run down to the data room. So you can see that I have basically all of the aspects of my projects are captured here. I have both the CCLU radios and all the accessories and license options which are captured very simply, but I have also all the non-CCLU related items which can be annotated here, and I can now should normally proceed again for all the different nodes and verify that all the equipment is exactly how I need it. And if I just happy with the basic content, I can leave it as is. If I want to make some additional additions, change a mounting kit, or add some more capacity at some other locations, I just go one by one. Again, all this is hyperlinked again. So where is this radio located? It's here. What are the nodes which are served? You can see that all of the information is available very clearly. I can now export all the result of this detailed bill of material review into an Excel file. And Excel is popping again on another window, which I will move here. So here is the result of the Excel file. And as you can see, all of the information that we had. So the name of the node, its location, the radio which was selected, did we do any change? We added the SFP. It is reflected here. The capacity license is also reflected here. The antenna is integrated. It is noted very clearly. And we have the additional information which was entered manually. So basically we have now a pick list which will allow us, when we have acquired or brought from the warehouse or acquired from a distributor all of the necessary equipment, we can now build a pick list for each and every site and make sure that all of the material necessary, CICLU and non-CICLU, to build the network will be dispatched to the correct location in the right quantities with the correct accessories, etc. So that is one option which is available here. We can also look at our bill of material summary and basically review how much is this going to cost. Because I had not entered any discount level in the project setting, I can I have nothing here, so I can either go back to the project setting very quickly and enter 10% here, save again, open my bill of material summary, and you see that the global discount is added. So I can now say, okay, that's going to be the total cost for the CICLU parts, with the radios, the support, the SFP, the capacity license. So all of the CICLU parts are reflected here with the relevant quantities. I can export this into another Excel file, and if I am an integrator, I can take this Excel file and include it into the quotation that I'm preparing for my customer, or I can send this to my preferred distributor and ask for them to confirm the list prices, the discounts, and the availability of all this equipment. So there are many different uses for this information. Once I have ordered and received all of the radios, what else can I do? I can create the configuration files for all of the radios in the project. And again, it's a small project, only a handful of radios, or maybe 15 radios to deploy. So one could maybe entertain configuring manually all of the radios, but all this can be done automatically here with the tools. I can put an IP address, for example, that will be assigned for the management IP address for all the tools. What should be the subnet mask? Is there a default gateway for the network? And if I want to utilize VLAN to isolate the management traffic from the rest of the traffic, I can do so here. If I need to send some SNMP traps, where do I send them? Probably not to the gateway, so let's just change this. Is there a UDP port, a community, a string, And in the case of point to multipoint, if I want to keep the default SSIDs and password, I can do so, but I can probably create something different, sector BBB and password AAA, so that this network will be isolated. And now I create basically the configuration files, in for all the radios. So a big zip file has been exported, and you can see here a file now for each radio, clearly identified by the name of the radio and the partner in the link. I will show just one of these links, one of these files. We have the name of the radio, the IP address, SNMP information. It's a terminal unit, so the sector and the password are set up here properly. And basically, by taking these files into the radios, one can basically ensure that the network will be deployed exactly as it was designed by the planner staff. There are also a few more inputs, such as the link summary, assuming that you would go on site and you are not sure that you will have access to the planner where you will go. We create an additional configuration file, file, which is basically a report of all the design information. So we have all the links, point to point or point to multipoint, are identified here with the radios at the two ends of the link. Where are they located? What is the distance of the link? Where is the antenna pointing to? In case of multi-hole, you don't have to worry too much about the azimuth, but in case you are designing point-to-point links with 1 foot or 2 feet antennas, you want to have a start azimuth to do your alignment very quickly. You have the frequency which has been assigned to the link or the pair of frequencies. In case again of a point-to-point link, you know what is your target RSSI for alignment, what is your operational RSSI, if there is going to be any interference, and right there you can see the IP address of each and every radio, as well as in the case of point-to-multipoint, what are the sectors, which units are in the same sector. So all of the information basically which reflects the design that you have been working on is available in an Excel file, which can be, again, shared across different team members or massaged in many different ways. And we can, last but not least, export all of the design information in a KML file again. Now again with all, for example, the IP addresses, etc. So I can export all my design again, and I have the site data as we have seen it before, the line of sight, but also the network design, and I have a link for every node in this design, whether we are talking about point-to-point or point-to-multipoint. They are all present here. You can see also the sectors that were created for this project. They are showing also in the KML. So basically a good reflection of the information that we had before, showing up now also in KML. If you want to share basically a graphical view of the design with other team members or with your partners or customers which may not have access to WiNDE, that is another way to share the information with them. So again, I think with that I've tried to illustrate a possible way to or some of the tools which are available. I'd like to go back to our slides. So we are, you may have some questions. What else is this tool complete? We do not assume that we are complete. We are working on a number of improvements in the tool, such as doing some more automation work on the line of sight validation, utilizing digital surface models or LiDAR data, allowing you to decide maybe where you want the base units to be located, creating extensions of networks. We have seen here that I started from 0, but many networks have already some amount of links in place, and you want to create extensions, connect additional nodes or homes or buildings into a network. How are we going to proceed? We are going to listen to what everybody has to say to us. What are your priorities? How should we improve the workflows, and more? You can always send us your ideas very simply. You can send us an email at planner-support@ciclo.com. Again, planner-support@ciclo.com, and give us your ideas, your expectations. Frequently, I visit people and talk to our partners. Our support team is also very engaged with many of you. Feel free to communicate with them as well and let us know what you would like to see. So what have we seen? We've seen all the software as a service aspect of the platform. We have seen how to perform manual line of sight validation with the correct azimuth and slopes for all the different lines, and very easy to go along KML lines on Google Earth to validate this. We have seen that the tool will very quickly create a number of options for you to decide which one is going to work best and respect all of your parameters, how the channels are assigned automatically and interference is validated. The bill of material is created with all of the defaults. However, you can augment it and manipulate it in a way which makes sense. And last but not least, we create configuration files so that you would be sure that the network is going to be implemented in the way you have designed it. So with that, I'd like to pause a little bit, look at the questions which were sent along the way and which I might not have responded so far. So very simply, yes, the recording for this session is going to be available in a few days. We will send you a link to where you can see it, and as well as responses to all of the questions which we'll be able to respond to this morning or not be able to respond to because we are going to be short on time. I'm going to look at a few more questions. Line of sight validations, there are a number of questions around this. So you have seen that we can very simply export all the nodes and the line of sights between them into Google Earth. In many areas of the nation, the data is really incredible. You can see trees and buildings and other man-made structures, shacks and whatnot on the roofs. So we believe that it is quite reliable. However, it is not perfect. It will give you an excellent approximation. at the end of the day, it is still, in some cases, desirable to go on site and validate visually that the line of sight is there. We have some tool chains in our back office which are ready to take LiDAR or DSM data, which will automate even more this kind of processes. But again, if we don't have LiDAR data from the last month, there might be a new building which has popped up if the data was from last year. So yes, again, we have seen cases where we could achieve 90% reliability or more of this line of sight validation, and if we can guarantee that in 9 out of 10 of the links will come up without doing site visits, and we only fail 1 out of 10, we think that it is a great improvement. And as the data is more readily available, we will improve on this process as well. Somebody is asking, what are the costs to utilize this tool? For the next 3 months, the use of the tool is completely free. You can run any number of designs, any size of network at no charge at all. Again, please send us any request to join or to get access to the tool via the email which I mentioned a moment ago, planner-support@ciclu.com, and somebody from our support team will contact you, take your user information, will create access for you. When we create access for a company, we have 3 types of 3 roles, if you want, of users. We have an administrator, which can create additional users for anybody in the company. We have planners, which can create design, and we have observers, which can look at designs. All of the users in a company have access to all of the designs in the company. We have a lock mechanism which prevents 2 planners to manipulate a design at the same time, and thereby creating consistencies. So the first user has control, and they basically lock the design. They can, if they log out, the design control is released, and somebody else can start making designs. At the same time, a number of persons can look at the design, but only one can make changes. Okay, what are the other questions? Somebody is asking if I'm doing designs utilizing E-band, 70-80 gigahertz. Do I have the information for FCC registration? If you looked at the Excel file, the link summary which I provided, you have all the information in terms of the location, the altitude, the azimuth, the type of the radios and their antennas. It's very easy to go from here to the FCC registration forms. We have an FCC registration form on the Ciclu website, and we will eventually create a completely automated process where one of the zip files which will be created by WiNDE will contain exactly the information in the right format to send to ComSearch or to any of the entities in the US doing registrations on our behalf, or that you could utilize if you have access directly to the FCC website for registration. That is another option as well. Can WiNDE do design of links at rooftop heights or at street level? The answer is yes. When we do street level, there is a default. You can just click the location along the street, and in the project setting, you can set a default for the altitude above ground. Because most of the time the street poles or the utility poles have the same height. So it's very easy this way to do it. And yes, the links which are created for the line of sight validation will have the correct altitude, height at the both ends of the links with the slopes, so that you can, just like you could see here in this very simple exercise, you can see where the slope is going to go with clear line of sight, or would go through a building, unfortunately, and that link would not work. Again, many areas in the nation have a very good representation in Google Earth, and when we introduce automated LiDAR validation, again, if you take very fresh data, that will be very reliable as well. What are the constraints that we can put in the design? Let me show you here, if I can go back to the tool. So the constraints that we can put are, first of all, in the project settings, the maximum device per node. So if I have, for example, poles which I should not load with more than 2 radios, for example, I can basically say, okay, let's set this number at 2. I can save again the project, and I can do my design again. And you will see that if I look in details, there is a single BU located here. There is 2 BUs located here as well. So we have probably not exceeded anything. Actually, we did in that case. The preference in WiNDE is always to create connectivity at the expense of not meeting all of the design targets. And in that case, I can see that there is an issue. Where is the problem? I click on this. I can open, and now I can check, where is the excess. So I can see that this node is loaded by more than 2 radios. There is another one where this is happening, this one here. And now it is up to the user to say, okay, I can either reinforce. I know that this pole is sturdy enough to take actually more than 2 radios, so I'm going to go along, or I'm going to have to go back to the drawing board and say, okay, let's do another round of designs from scratch, and see what happens in this case. So again, the preference in WiNDE so far is create connectivity, and if you cannot meet all of the constraints, it will be reflected in either here in the limitation reports, in the limitation curves, sorry, and it will also be reflected in the constraint compliance report. If I'm pressed for time, like we am here, I do not have to go through all of the 20 iterations. I can stop at any time and look at maybe this design here, which seems to have good performance as well as lower cost again. And again, as I've done this, my bill of material has been updated, etc. So all of the information is always consistent. Again, there are additional levers in the tool, such as the hop count, the preferences for how many channels to utilize in the frequency allocation. A lot of flexibility is there. I encourage you to look for what is going to be important. Tell us also what is going to be important for you, and we'll try to change the way WiNDE works. Can we, another question here, can we optimize a design for cost? So, WiNDE, tries different variations on cost and performance, as you can see here. If cost is very important, I'm going to look at the green curve and at the lowest points and select the lowest cost designs. I can see that some of them do not have very good performance. Some of them have, these two here have similar cost to these two designs here. These two designs have better performance than these two designs, so I would choose one of these two. That's the way to optimize for performance or for cost, depending on what is the preference for the organization. I see that more questions are coming through. However, we have already extended our time for this morning. I really want to thank you all for taking the time to listen, participate, send questions, learn about what this tool can do. Again, if you are interested in trialing, please send us your request at planner-support@cyclo.com or wait for the recording and then decide that you want to trial. Again, the next 3 months are going to be for free, and in about 3 months we'll announce what is going to happen for the next steps. What are the options for which we are going to charge because of the complexity or additional costs, such as acquiring LiDAR data, for example, which we cannot sustain on our own. Thank you again for listening. Have a good day and talk to you all soon.